So, very good morning, students. Welcome to IIT NEET Foundation or Focus C program by the Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 9th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Our ongoing chapter number 2, motion in a plane. And today we are entering into the session number 3. So far we completed the 2 classes after completing the first chapter, which is basic mathematics in physics. So we done 2 sessions of motions in a plane, which is the continuation of your 8th class, motions in 1 dimension. This is motion in 2 dimension. That is motion of a body along x-axis and along y-axis. So we are discussing about the basic concepts what we left in the 8th class, what is motion, types of motions and all. Then we enter into what are the different types of 2-dimensional motions. So we'll continue where we left in the last class. But before that, when you recall, so we have seen how a body follows the path when projected from ground and reached again to ground. That is parabolic path, which is called oblique motion, oblique projection. So we discussed about oblique projection in the last class, how the path followed and how the vertical and horizontal components divides, and we derived the formula for what is the maximum height reached, what is the range, and what is the time of flight. All these things we discussed for the oblique motion of the body, right? So today we are going to discuss second type of motion, that is horizontal motion. When you are on certain height, either from building or from aeroplane, anywhere, when you are dropping a body, how the body will follow the path. That is called, for example, you are on the building and you are firing the bullet. Bullet will follow certain path. That is horizontal projection. Oblique projection is nothing but ground to ground, which is follow the path of parabola as per mathematics. We derived also. Ax plus bx square form we got. But now the second type of motion is little different, which is horizontal motion. So today we are going to discuss about the horizontal motion, right? So this is the horizontal motion from the top of a tower. After discussing about first part, the projectile motion, now we are discussing about horizontal motion, that is page number 54 of the material. So horizontal projection from top of a tower. Suppose this is a tower with a height of h. We are here. We are projecting the body. We are not dropping the body. Dropping means freely falling. We are applying some force, some velocity u, and we are projecting in the direction of x. So what happened? Body will follow like this and strikes here. So this is called horizontal range. We derived the formula for oblique projection. See, previous one like this. This is ground, from ground. This is for oblique projection. So here it is the horizontal range, maximum distance covered. But body is from height to here. It is a different type of projection, that is called horizontal projection. Suppose a body is projected horizontally with initial velocity of u from the top of the tower, height h, at t is equal to 0, some initial time. As there is no horizontal acceleration, the horizontal velocity remains constant throughout the motion. See, coming down like this. So velocity is resolved components, vertical and horizontal. Hence, after t, the velocity of horizontal direction will be, right? So ux become u, uy becomes 0. There is no vertical velocity. Only horizontal velocity is there. Let the body reaches the point P. Okay, it reaches some point P. It come up to here on the way. Some conditions we are derived here. Some formulas we are derived here whenever bodies come to some point. At different points, you have to find out, right? Just see here. So if the body is projected horizontally from the certain height with velocity u, its path would be a parabola from height. So here along horizontal direction, when you discuss about horizontal direction, so acceleration is 0, there is no acceleration. Ux is equal to u along x-axis velocity, because we throw with some velocity. We are projected with some velocity. For x coordinate, after t seconds, x is equal to ut. That is, distance is equal to velocity into time, common only. So what is the distance here? Covered is x. U is the velocity, t is the time. Okay, horizontal velocity is constant. So we'll get t is equal to x by 2 from here. So it's a common formula. Distance is equal to velocity into time. From that, time is equal to distance by velocity. Right? That's what we wrote here. Along vertical direction. Vertical direction acceleration is gravitational force. So acceleration is g. There is no horizontal velocity, vertical velocity. Only horizontally projected. So u is 0. If vy is the velocity of the particle at any instant t, vertical direction, vy is equal to same. Acceleration into time. Velocity is equal to acceleration into time, because acceleration is equal to rate of change of velocity. So we got velocity, vertical velocity is equal to g into t. Right? So these are some conditions for two cases, along the vertical direction, along the horizontal direction. In vertical direction, there is no acceleration. Velocity is u. In horizontal, in vertical direction, acceleration is g and velocity is 0. So one is 0, other is value in both cases. Then when you move, apply. So y is the distance traveled by the body in vertical direction. Then y is equal to, ut plus half at square. S is equal to ut plus half at square. In vertical direction, half at square only, because u is 0. There is no velocity vertically. So half at square will get. So like that, you get the formula here for different formulas for the constant velocity. This equation represents the equilibrium of parabola. They came in the form of y is equal to kx square. Previously, y is equal to ax plus bx square. What we want to show is whether you are projecting the body obliquely or horizontally, the path followed by the body is nothing but parabola. Right? After showing that the path followed by either oblique projection or horizontal projection is parabola, now we have to discuss about the conditions for the horizontal projection from the tower. Some formulas we have defined for that, right? So here we have, as we derived for the oblique projection, here also we have to time of descent. Time taken by the vertically projected body to reach the ground. Because we are projecting from some tower, right? When you are projecting from tower, after projection, you will travel some distance and reaches the ground. So the total time taken to reach the ground is called time of descent. Here there is no time of ascent because we are projecting from the height. So if the time taken by the body to touch the ground after it's projected from the height is h. Suppose we are projected from height h. So y is equal to h, that is distance traveled. Time is equal to some taken time of descent, td we have taken. T is equal to td, time of descent. We get. So formula, same formula. As you know that S is equal to ut plus half at square. So as there is vertical velocity 0, initially 0 here. So S is nothing but h, height. Half A is nothing but g. T is nothing but td square. You can write td square. From this you can get what is the td value. You want td is equal to, take to this side, it becomes 2h by g. Td square is equal to. So Td is equal to under root of 2h by g. Is the formula for the time of descent. If you know the h value, from how much height you are projecting, you can get the Td value, because g value is constant, 9.8 or 10. So the formula for time of descent, the time taken by the vertically projected body from tower is given by Td is equal to under root of 2h by g. Whereas for oblique projection, angle comes. As there is an angle is there, we'll consider cos theta or sin theta. Here there is no angle. We are projecting horizontally. That is first case. The first special case, that is time of descent. The second one is range. What is range? Suppose you are throwing from here. So body comes like this and fall here. So from foot of the tower to the body where the body reaches, that is called range. The maximum displacement of the body from the ground. Range. So the maximum horizontal distance traveled by a body while it touches the ground is called range. So as the horizontal velocity is constant, the range is equal to horizontal velocity to time. So range is nothing but distance only. Distance is nothing but velocity into time. So we have taken horizontal velocity. So that is, again, same formula we have. Range is equal to velocity into time. So what is velocity here? U only. What is time or time of descent? You can take. That is 2h by g. So u into 2h by g is the formula for range. By knowing the initial velocity and h value, you can get the how much distance it can travel. We have seen for oblique also. Right? So u into 2h by is the horizontal range. So 2 points we discuss. One is time of descent, time taken by the horizontally projected body to reach the ground. And second is range, how much maximum distance is covered from the ground when it is projected from tower, which is given by same formula, velocity into time. But in place of time, what we have to take? Time of descent, total time. So that is u into under root of 2h by g. Right. Then third case, third parameter is velocity also you can calculate. Right. So velocity of the projectile anytime. So let the bodies point after the time t. So when you project it horizontally, after some t seconds, the body reaches the point P here, assuming. Says point P. Let Vx is and Vy are the velocities at x and y directions. So as it is two dimension, see they are components, they are resolving into vertical and horizontal components of velocity. Vx cos theta, Vy sin theta. The horizontal velocity remains constant, that is Vx is equal to u. With what you are doing? The velocity along y-axis. So v is equal to u plus at formula. You know, first formula, first equation of motion. What is u here? Vy. Right? And at is equal to a nothing but g plus gt. It is a horizontal velocity. Okay. Vertical velocity is vx is equal to u. Horizontal vy is equal to this. So uy is equal to 0. The initial velocity of vertical is not there. The body is thrown horizontally. So Vy is equal to gt. Velocity is equal to acceleration in time. So magnitude of the velocities. Magnitude is nothing but under root of Vx square minus Vy square. But what is Vx square? Vx square is nothing but u square. And Vy square is nothing but g square, t square. Substituting these values, 1 and 2. So we get this formula. If the velocity V makes an angle alpha, tan alpha is equal to formula gt by u, Vy by Vx. Formula is there. We derived in the case of parallelogram law. So from that alpha value, you can find out what is the angle by using tan inverse gt by u. So this is the vertical velocity is found by under root of u square plus g square t square. And angle, that is called magnitude. And direction is given by alpha is equal to tan inverse of gt by u. Right? So these are the derivations. We need to remember the formulas first for solving any problem. Okay. Some important note is given for the same thing repeatedly. So these are all different cases where we can understand the concept of horizontal velocity, horizontal projection. So there are two types of two dimensions. One is oblique projection, when you are projecting from the body from the ground and the total power of a ground is given by parabola. There we calculated the different cases of what is time of ascent, time of descent, horizontal range and velocity and all. The second case is when a body is projected, not thrown, projected from the height of the tower, some height. Then path forward also is given by derived by parabola only. There also we find what is the horizontal range. So what is the velocity, magnitude of velocity, direction of velocity and all, right? So next to the last part of the chapter, the relative velocity. before going for this, let me show you one video on projection. Then we'll move to the, just listen carefully.
Of straight lines at uniform acceleration. So it can be constant acceleration or the horizontal or motion in a straight line. And of course, the vertical motion or what we call the free fall. In this lesson, we're going to discuss about the projectile motion. Specifically, at the end of this lesson vlog, you'll be able to know or you'll be able to learn and to define what projectile and projectile motion is, illustrate the path traveled by a projectile, and for number 3, you have to appreciate the application of projectile motion in relation to sports. Hello my dear students! Welcome back to my YouTube channel. This is me once again, Teacher Tin, your science teacher for today. So, if you're new to this channel, don't forget to subscribe, like, and hit the notification bell for more updates. In Science Now. Do you still remember the topic that we discussed about uniform acceleration? Ano nga ba pag sinabi nating uniform acceleration? So when we say uniform acceleration is when the speed of an object changes at the same rate. Yes, kapag yung bilis ng isang bagay, let's say for example, yung isang kotse, so yung bilis na ay nagbabago, pero parehas lang yung rate, itong tinatawag natin na uniform acceleration. And did you know that this has something to do with what we know as kinematics? Because this uniform acceleration leads to the study of motion using the equations known as the kinematics. Knowing the details, kagaya ng kung gaano kabilis ang isang object, kung gaano kabilis siya gumalaw after given an time interval, rather than just the fact that the object is moving, that is our primary interest in today's lesson. So to describe the properties, not just the properties but the characteristics, behavior of the motion with greater detail, okay, so meron tayong mga equations na kailangan nating i-discuss for today. Ano-ano nga ba yung mga equation na yun? So, ihanda nyo ang sarili ninyo dahil maraming mga equations ang may kinalaman dito sa tinatawag natin na kinematics. Okay, so before we discuss about the 4 equations involved in kinematics in horizontal motion, so let us discuss first kinematics. Ano nga ba yung paulit-ulit nating naririnig na kinematics? So, this kinematics is a branch of physics that defines motions with respect to space and time, ignoring the cause of that motion. Yun yung tinatawag natin na kinematics. And that kinematic equations are set of equations that can be that can derive from a known aspect of a body's in motion in other aspects that are provided. So ngayon, dun sa ating ibibigay sa inyo na equations in kinematics, so, magkaiba ang sa horizontal at saka sa vertical motion. So, these equations links 5 kinematic variables. Kaya, pag nakita nyo itong mga variables na to, dapat alam nyo na, okay, this one is for displacement, ito ay para sa initial velocity, and so on. So, again, these equations link 5 kinematics variables. So, these are the 5 variables that involves in the kinematic equation. The first one is the displacement. Pag may nakita kayo nung parang triangle na may x, so, di ba, that's, kung magbabasahin mo, change in x, or that x denotes the displacement. So, again, displacement is denoted by that triangle x, or change in x, or change in displacement. While that VO, yung V tapos merong subscript na 0, that is the initial velocity. And di ba, nung nakaraan naman natin mga discussion, pag sinabi natin VO, that's initial velocity. The third one is the final velocity. So, ang final velocity is denoted by letter V. Yung symbol na V, that is the final velocity. And of course, we also have the small letter t. That small letter t is for the time interval. Again, the time interval is denoted by the small t. And of course, the last one is the constant acceleration, which is denoted by small letter a. So, tatandaan nyo yung 5 variables na yan na gagamitin natin sa equations na ipapaliwanag ko mamaya. Okay, so these are the 4 basic kinematic equations. The first equation is V is equal to initial velocity
so much lengthy
plus
explanation.
Acceleration times the time interval.
So we'll go for one more video apart from this. Okay. So anyway, that is there. There is a long elongation. Is there so much they are spreading? Before going for this, starting from the beginning, their explanation is given. So clearly, it's clear that whenever a body is projected from the ground, the path followed by a body is called projectile, and that motion is called oblique projection. And second one is when a body is projected from height of the tower or building. Projected, we are not dropping. Dropping means pretty falling. U is equal to 0. But we have some velocity u. When it's thrown with some velocity u, it follows the path again called parabola and covers some distance called range. All the formulas we discussed in the both cases. Now, the last part of the chapter, very important is relative velocity. Means comparing. Relative is nothing but comparing one velocity with other. For example, you are sitting in a train. Train is moving. Somebody is on the platform. Or, right? He is rested. When you observe this moving train, the person sitting in the train feel that a person on the platform is moving. But person standing in the platform feel that the person sitting in the train is feeling. That is comparing. Comparing velocity of one body with another body is called relative velocity. This is possible when body is rest, other is moving. When second case, when both the bodies are moving in same direction, or when the both bodies are coming in opposite direction. Various cases you can calculate the relative velocity, and you can, very important concept in physics where we come across in our day-to-day life also. So when you are driving any vehicle and all, you have to keep in this mind of this. So until now, the general, we discussed those cases in which frame of reference is fixed generally to the ground. However, in certain applications, it is often advantageous to analyze the motion with respect to moving frame of reference. Till now, what we have done from ground to ground or from height to ground, there is no motion. But here we are taking the frame is moving. In such case, what to find? Okay, so these are known in now at the this you can see. The equation of motion corresponding constant can also be applied to the relative motion provided relative acceleration is constant. So where you applied it means you can apply this further even for equations of motion. If you drop particle from moving car. So for example, when the car is moving on the road, you are on top traveling by some aeroplane. When you drop anything from top, that body should fall on the vehicle on the ground. For that, you need to apply the as per relative velocity. With that, otherwise, when you are dropping, the velocity is very important with which body is traveling, as which you are dropping the ball. According to that, only you can hit it. Suppose somebody hit the bomb. You want to drop the bomb on a building. Example. So what you have to do, keep you of relative velocity. With what velocity you are dropping, with what velocity you are moving. Right. So see, very interesting. If you drop a particle from moving car, then let us say that a instant dropping the ball, the velocity of the car is v, and acceleration of the car is, say, a. At instant of dropping velocity of the particle with respect to car is 0. But with respect to the ground, it has some velocity due to motion of the car. When a person is dropping ball from the moving car, but as long as ball is in his hand, he is moving with the vehicle velocity. But when you drop the body, the velocity will change. Okay, the conditions there. So you consider two bodies, A and B, moving with the velocities. Then the velocity of A with respect to B, that is called comparing one with another is called relative. A with respect to B is nothing but VAB is equal to VA minus VB. Right? When they are moving in the same direction. Okay, so for a simple example, I'll tell you. You are standing in a platform, railway platform, right? When train is coming towards you with some siren, we can hear a lot of heavy sound of the siren. But when it is crosses away from you, sound will reduce. That is relative. Relative velocity of you with the train, a train with you. When both are moving, that time the sound effect is different. When both are moving in opposite direction, the sound difference is different. Suppose you are coming in one train, other train is crossing you. The train velocity and this train velocity minus into minus become plus. The velocity become double, so that's the reason you get horrible sound. Observe carefully. You are sitting in one train. Your train is coming from Hyderabad to Vizag. Other train is coming from Vizag to Hyderabad. Both met at one place, crossing at one place. At that crossing, we can hear horrible sound. Why? Because this velocity minus of minus this opposite direction. Na? If they go same direction, get minus only. VA minus VB. If they go opposite direction, VA minus of minus VB. So VA plus VB. Both velocity together, you can get the sound. Very interesting. That is called relative velocity. Comparing of one velocity with another. Comparing velocity of A with velocity of B is called relative velocity of the body. Right? So there are so many things to discuss about these conditions. So to find the closest distance of approach between two particles, conditions for the collision of two particles. So different these are not that much applicable for us. And projectile motion from the moving vehicle. So very interesting. See here. So first what we have seen, we thrown the body from ground. There is one kind of projection. Next we got thrown the body from the horizon. That is tower. That is one kind of projection. One is moving car. From moving car we dropped. That is different. And here again same. Projectile means projecting the body either height or horizontal. Moving car. There are two cases given. When a body is, see here, first case, when a body is thrown upwards from the truck moving with the uniform speed, see, they move upwards. Car is moving, we thrown the ball upwards. Then the observer A standing on the truck will see the ball moving in a straight vertical line. The observer B here, A, B, two are there. This fellow is there here, he thrown the ball, moving car upwards. So what he feel? The body move vertically upwards. But the observer B sitting on the ground will see the ball moving in the parabolic path. That fellow feels like that. Only this is because of the relative, comparing one velocity with other. Okay. Clear? That is what special cases there. They may come across in our day-to-day life for sometimes, but you need to focus on this. Case 2 you can see here. Case 3, so many cases are given, whether he's throwing right side or left side. When a ball is thrown at some angle theta in the direction of motion of the truck. So truck is moving in this direction, throw like this with angle. Second case, if you throw other direction. The third case, other direction if you throw opposite to the truck direction, what happens? Right? So different special cases there. Fourth again, when the ball is thrown at the angle of some angle theta from the platform moving with the speed v, moving platform. So many cases you can see. All these are comes under the projection of the body. Rain problem. When you are holding the umbrella, what angle rain will fall? If the rain fall this angle, what we can do? With what speed you can walk so that you can protect ourselves from the rain. These all are comes under the special case only. Special cases of oblique projection, horizontal projection, and parabolic path followed. Some are without angle, some are with angle. Okay. So these all we can learn in details in the higher classes. Right now we need to have some idea about these particular motions, normal motion, horizontal motion, vertically projected motion. All these, so many formulas are there. Just go through. If you have any queries, you can check with the key provided for you. Right? So that's all for today. Next class, we'll start the new chapter. the third chapter, number 3. Until then, have a nice day. Thank you, all of you.